MCT4C, lesson 1.3, finding angles, part 2. On to example C. Cos of theta equals 0. Now, if you remember from your chart, right, where is the cos of theta equal to 0? Well, 90 is one answer here, straight from the chart. But what's weird is, you know, this gave us another answer. There's usually two answers. And we kind of have to think about this in a different way. These special ones. These special ones, I mean, like 0, 90, 180, 270, 360 are all what I would say special angles, because, you know, I think of cos of theta being 0. Well, is it positive or is it negative? We use that in the cast rule to figure out which quadrants they're in. But when it's 0, it's neither positive nor negative. So which quadrant? And in fact, one way we think about this is the unit circle. Nice way to think of this. And again, this point, a point on a terminal arm here. Let me get a terminal arm. This point here, right here, it's got coordinates x, y. Well, remember, the x coordinate is the cosine and the y coordinate is the sine. So I'm interested in, when is the x coordinate equal to 0? I'm thinking, when is the x coordinate equal to 0? Notice that at this spot, an angle of 0, the x coordinate of that point right there is 1. And then as that increases to 90, well, there's one of our points that we want right there, right? Because that's got the point 0, positive 1. An x coordinate is 0, the cos is 0, and the y coordinate sine is 1. There's one of our answers right there. And that's the one we knew from the chart anyway. So, but if we keep going here, right, we keep going, grab our line, there's an x coordinate of negative 1, and I'm looking for, is there another spot where the x coordinate is 0? Yeah, right there. It's 0, right? Because this is the point. This point, I'm going to use a different color here. That point right there, that's going to be theta 2. And this point has the coordinates 0, negative 1. And again, I've got an x coordinate of 0. So this equation has two solutions. Theta equals 90. Theta equals 270, right? That's 90, 180, 270 is 3/4 of the way around. And in my diagram, that's theta 1 and that's theta 2, although these are the two solutions there. And if we got a part D, yes, we do have a part D. Tan of theta is negative 7/24. Well, again, let's draw a diagram. This isn't one of our special angles, right? This isn't from our chart or from our triangles. 7/24 isn't exact. So at some point we're going to have to use our calculator. But let's start thinking about, first of all, where our solutions, what quadrants their terminal arms are, right? Well, all soup turns cold. I think of, where is the tangent negative? Well, all of them are positive here, and the tangent's positive here. So these solutions, theta, should be in the second quadrant and the fourth quadrant. So let's draw them in there. And again, I don't really care where this is, you know, where this is. But I know that this is going to have the same reference angle. So this angle here is going to be equal to this angle here. So that angle and that angle are the reference angle. I'm going to even draw that in there. Why not? Now, there's a couple of different ways to attack this, actually. We could think, because tangent is just opposite over adjacent, we could start thinking of it that way, right? And then where if we wanted to, we can draw a triangle. Opposite is 7, adjacent is 24, and we could start finding out what alpha is that way, or what the reference angle is that way. That's, you know, and that's one way to do it. Another way is, well, let's just pretend like we're back in grade 10 and find out what the reference angle is using our calculator. This isn't one of our special angles, so let's just go tan theta equals 7 over 24, inverse tan of both sides, right? Tan minus 1. Watch your calculator steps there. My calculator, I got to go 7 divided by 24, not 25. 7 divided by 24 and get that answer before I do the inverse sine. You might be able to put, or inverse tan, you might be able to put that in one step. So my reference angle is 16 degrees. About. So that's my reference angle. And maybe I should have labeled this alpha because I know my two solutions, one here and one all the way around here, aren't going to be, neither of them are 16, but 16 is the reference angle. So here if I write theta 1, how am I going to get what theta 1 is? If this is a 16-degree angle, it's 180 subtract 16, which is 164. Or this green one here is all the way around except for the reference angle. 360 subtract 16. What's that? That's 344. Done. Those are our two solutions. Still approximate because our reference angle is approximate. Okay, what do we got here? The point Q is on the terminal arm of the angle A in standard position. Draw a diagram, determine the primary trig ratios. This sounds like something we've done before. All right, well, I don't know how exact we have to be, but let's try. 5's there, so that's 5. 2, 4, 6, 8, 10, 12. I might have miscounted, but it doesn't really matter. There's Q. Bit of a mess. Okay. And there's our terminal arm. There's angle A right there. Right there. That's A. You can see our triangle. There we go. Determine the primary trig ratios for A. Now it hasn't told us, you know, whether we want to be exact or what we're doing here, but I think we can be. We can be exact. We've done this sort of thing before. Sine of A, cos of A, and the tan of A. What's nice about the tan of A, we got that already, right? Tan of A is just opposite over adjacent, 12 over 5. But we've got to calculate the hypotenuse, the radius, to be able to get the other two. Jam that into a calculator. I think you're going to get the square root of 169, which is 13. So the sine is opposite over that, 12 over 13. Cosine is 5 over 13. It's all good. How determine the measure of angle A? Well, this doesn't mean with a protractor. It means, you know, use a calculator. Find out what A is. I'm going to do the inverse tan. Why not? Was the first one. But it doesn't matter, right? And jam that into a calculator, and you get that that's 67 degrees. Try that on your own. Make sure I didn't mess that up. How would your answer for parts B and C change if point Q was reflected in the y-axis? Well, the y-axis is right there. So if this point was reflected in the y-axis, it would be over here. So I'm going to pretend, put a little Q dash there, and think about what would change. Well, we know from the cast rule, all of them are positive there, and we saw that here. All these are positive. But what ones are positive in this quadrant? Only the sine, right? So sine would be the same. The cos of A and tan of A would be negative. And what would the angle be? Well, we'd still have the same reference angle, it's the same triangle. It's just be this angle here. I'm going to even make that red. Why not? That angle there, the new A, is just 180 minus the reference angle. The reference angle was 67. It's 113 degrees. And that's it for today.